In this video, I am going to explain types of attacking reagents. First of all, what is attacking reagent? As per chemical reaction, A plus B gives rise to some intermediate or transition state. This transition state finally gives product. These two are A and B are here said to be reactants, and P said to be product, as we discussed in our previous video. Okay, so reactants are two types. One is substrate, other is reagent. What is substrate? Substrate is the reagent, substrate is the reactant which provide carbon atom for the new bond formation. Substrate is the reactant which provide carbon atom for the new bond formation. Then what is attacking reagent? What is reagent? So reactants are two types. One is what? Substrate, other is reagent, attacking reagent or simply reagent. Reagent, attacking reagent, both are same. What is attacking reagent? So in this video I am going to explain attacking reagent, types of attacking reagents. So what is attacking reagent? It is the reactant. Attacking reagent is, first of all, that is the reactant which forms a new bond with carbon atom of substrate molecule. It forms a new bond with carbon atom of substrate molecule. Substrate provide carbon atom and attacking reagent form new bond with that carbon atom. Thus a bond formation takes place. Attacking reagents are two types. They are electrophiles and nucleophiles. Attacking reagents two types. They are electrophilic reagents and nucleophilic reagents. Electrophiles are electrophilic reagents. Nucleophiles are nucleophilic reagents. Total they are two types. Electro means electron. What is meant by electro? Electro means electron. Phile means loving. Electron loving species. The species which has attraction towards electron is referred to as electrophile. The species which has attraction towards electron, the species which loves electron, the species which is seeking for electron is said to be electrophile. So electrophile attack on negative site of substrate, because in substrate, for example, this is substrate. So if it is negative site, it is positive site, then electrophile readily attack on, since it is electron loving species, it attack on negative site of the substrate. So electrophile is reagent which attack on substrate at which site? Negative site. Okay, so electrophile is the attacking reagent which always attack on the negative site of substrate molecule. Electrophiles are again two types. They are positive charged electrophiles and neutral electrophiles. Electrophiles are two types. They are positive charged and neutral electrophiles. Electrophile means electron seeking species, electron loving species. So being it is electron deficient, it always seeking for electron. Electron deficient species are electrophiles. Simply electron deficient species are electrophiles. Electron deficient species are electrophiles. So electron acceptor, simply electron pair acceptor, just like our Lewis acids. So Lewis acids are electrophiles. So electrophiles are two types. They are positive charged electrophiles and neutral electrophile. What is positive charged electrophile? H plus ion, R plus ion, alkyl group with positive charge, nitro group positive charge, and sulfonic group positive charge, acyl group positive charge, and halogen positive charge. So all these are species which are carrying positive charge and they are electron deficient. They are seeking for electron. Note, if you see NH4 plus, NH4 carrying, in NH4 molecule nitrogen carrying positive charge, but it cannot act as electrophile, because if an electrophile accept electron, there should be some vacant orbital. If you see in H plus ion, there is vacant s orbital. If you see some alkyl group on carbon, vacant p orbital, nitro group, vacant p orbital, sulfur, vacant p orbital. Here in acyl group, carbon has vacant p orbital. In halogen, vacant p orbital. Vacant p orbitals must be present to accept electron pairs. So vacant p orbital, vacant d orbital. So if you see in NH4, if nitrogen accepts electron pair, there is no p orbital. Due to absence of p orbital, so it cannot accept electron. Even though it has a positive charge, it cannot accept electron pair. It cannot accept electron. So there is no orbital to accommodate electron accepted by this species. That's why this is all positive species are not electrophile. Here NH4 is not electrophile. H3O plus is also not electrophile. There is no vacant orbital to accept electron pair accepted by it. Okay, next one. Second category of electrophiles are neutral electrophiles. What are neutral electrophiles? They are not carrying positive charge. They are not carrying positive charge, but in their central atom, the molecules in which central atom carrying positive, central atom containing vacant orbitals are electrophiles. For example, here neutral electrophile, the neutral molecules which have vacant orbitals in their central atom are neutral electrophiles, not nucleophiles. Neutral electrophiles. Neutral electrophile. Neutral electrophiles. Neutral electrophiles. So the molecule in which central atom carrying vacant p orbital, they are electron deficient molecule and they have vacant orbital for accommodate electron are electrophiles. So in BX3 molecule, if you see BX3 molecule, central atom boron contain vacant orbital. In B2H6 boron contain vacant orbital. In AlCl3 molecule, aluminum contain vacant orbital. Carbons also, in carbons also there are 6 electrons, so they are electrophiles. SO2 vacant d orbital is present in sulfur. SO3 molecule, PCl3, PCl5, all these species having vacant d orbital. So with their vacant d orbital they can accept electron, that's why they are electrophiles, neutral electrophiles. They do not carry any charge, but they act as electron seeking species. So electrophiles two types, positive charged electrophiles and neutral electrophiles. Okay, take this one. See, second type of attacking reagents, they are nucleophiles or nucleophilic reagents. What are nucleophile? What is meaning of nucleophile? Nucleo means nucleus, phile means loving. Nucleo means nucleus and phile means loving. Nucleus loving species, nucleus seeking species. What is charge of nucleus? Positive charge. So the species which are loving positive charge means they are negative, electron rich. Electron rich species always seeking for positive charge. That's why electron rich species are said to be nucleophiles. The species which attraction towards nucleus, the species which has attraction towards positive charge, nothing but, is said to be nucleophile. So nucleophile attack on positive site of substrate molecule. Nucleophiles always, suppose this is the substrate and the nucleophile. If X is more electronegative, then X become partial negative and R become partial positive. Now nucleophile attack at positive part of the substrate. So this is substrate and nucleophile is reagent. So nucleophile is a reagent which attack on positive site of the substrate. That is my point. Nucleophiles are two types, similar to electrophiles. Nucleophiles also two types. They are negative charged nucleophiles and neutral nucleophiles. What are negative charged nucleophiles? H minus, OH minus, carrying negative charge. RO minus, cyanide, hydride, hydroxide, alkoxide, cyanide, halide, and what? Alkyl carbene ion and acetate ion, amide ion, and hydrogen sulfide ion. All these are what? Negative charged nucleophile. All they are seeking for nucleus. Next, neutral nucleophiles. So what are neutral nucleophile? The molecule in which central atom contain lone pair electron. One or more lone pair electrons are said to be nucleophile. They act as nucleophile. The molecule in which central atom containing lone pair electron, one or more lone pair electrons, said to be nucleophile. H2O molecule, there are two lone pairs on oxygen. Alcohol molecule, oxygen has lone pair. Ethers, ammonia, amines and tertiary amines. All these molecules have lone pair electron, one or more lone pair electrons on their central atom. And the molecules which have multiple bonds between similar atoms. The molecules which have multiple bonds between similar atoms, said carbon between two carbon atom, double bond between two carbon atom, triple bond also act as nucleophile. Okay, take this one. See this one, nucleophilicity and basicity. What is nucleophilicity? Nucleophilicity is the tendency of nucleophile to attack on substrate. How much tendency it has, how much strength it has. Okay, whereas basicity is the tendency of a base to donate proton. How much ability it has, how much tendency, how much strength it donate proton to acceptor. So both are different terms. Of course, some species have both character, nucleophilic character and basic character. Both characters may be present in a single species, but both are different characters. Species may have these two characters. So what is nucleophilicity? Nucleophilicity is the ability, it is the tendency of a species nucleophile to attack on positive site or positive site or nucleophilic center of the substrate. On substrate where the electron deficient, what is nucleophilicity? The substance which has tendency to attack on substrate. Okay, what is basicity? Basicity is the tendency to donate electron pair to electron pair acceptor. So nucleophilicity is kinetic term, whereas basicity is thermodynamic term. This is basic difference between nucleophilicity and basicity. Nucleophilicity is kinetic term. It means it talk about how much time, in how much time the nucleophile attack on the substrate. Some nucleophile takes less time, whereas some nucleophiles takes very high time to attack on nucleophile. It talk about speed. Kinetic term means it talk about time, it talk about speed. Basicity means, basicity is thermodynamic property. It means, it talk about the amount of energy released upon when a base react with acid. Some bases react with acid when more amount of energy released, whereas some bases react with acids less amount of energy released. So if basicity is more, they releases more amount of energy. If basicity is less, they release less amount of energy. That means it is thermodynamic property, means it talk about amount of energy released. Basicity more amount of energy released. Basicity is less amount of energy released. Thus basicity is thermodynamic property. Nucleophilicity is kinetic property, means, so if a nucleophile has more nucleophilicity, then it attack on a substrate very fast. If a nucleophile has less nucleophilicity, it attack on substrate on more time. It takes very large time. Okay, so rules for comparison of nucleophilicity and basicity. There are 5 rules which are used to compare nucleophilicity and basicity. So in that, first one is rule 1. Negative charged species are stronger nucleophiles and as well as stronger bases when compared to corresponding neutral species. Negative charged species are stronger bases, stronger nucleophiles when compared to their corresponding neutral molecule. See here, OH is stronger nucleophile compared to water, NH2 stronger nucleophile compared to ammonia, acetate ion stronger nucleophile compared to acetic acid, phenoxide ion stronger nucleophile compared to phenol. Thus, negative charged species are stronger nucleophiles when compared to their corresponding neutral species. This is order of nucleophilicity. Take this one. See next, during comparison of nucleophilicity and basicity, second rule, when donor atoms are same. If donor atoms are same in species, then nucleophilicity, basicity follow same order. If donor atoms are same, then nucleophilicity and basicity follows same order. Exception, of course there are some exception. See, in methoxide, isopropoxide and tertiary butoxide, donor atoms are same. Oxygen donor atom, oxygen donor atom, oxygen donor atom, but their nucleophilicity and basicity do not follow same order. Nucleophilicity order A greater than B greater than C, but basicity A less than B less than C, different order. Exception is there, but above point same order, they follow same order. Whenever donor atoms are same, they follow same order. These four are exceptions. Here donor atoms are same, but they do not follow same order. Here order is decreasing, here increasing. In hydrogen and ammonia, so in which donor atoms are same, nitrogen donor atom, but nucleophilicity do not follow same order. Nucleophilicity A greater than B, basicity A less than B. Next, see here, hydrogen peroxide and water, nucleophilicity A greater than B, basicity A less than B. Of course donor atoms are same, oxygen only. Here hydroxylamine and ammonia, donor atoms are nitrogen only, but nucleophilicity A greater than B, basicity A less than B. That means in these four cases only, nucleophilicity, basicity do not follow same order. In remaining cases, whenever donor atoms are same, they follow same order of nucleophilicity and basicity. Take this one. See the rule number 3, when donor atoms belongs to same period. If donor atoms in two species belong to same period, then from left to right basicity decreases and nucleophilicity also decreases. So when you see here, when you compare here basicity, nucleophilicity decreases like this. When carbon, nitrogen, oxygen, fluorine, from left to right basicity what happens? Decreases, and nucleophilicity also decreases. Compare it to ammonia, water molecule has less basicity, less nucleophilicity. So nitrogen, oxygen belongs to same period. Nitrogen, oxygen belongs to same period. This is ammonia hydride of nitrogen, water is hydride of oxygen. Next, phosphorus, sulfur, chlorine belongs to same period. They are third period elements. So in a period from left to right, what happens? Basicity, nucleophilicity decreases. Hydride of phosphorus, hydride of sulfur. Phosphorus and sulfur belongs to same period. Then from left to right, what happens? Basicity, this is order of what? This is order of nucleophilicity and basicity. Nucleophilicity and basicity order. Take this one. See the next rule, rule number 4. In previous rule, rule number 3, whenever donor atoms are belongs to same period. This is rule number 4, whenever donor atoms of species belongs to same group. When donor atoms belongs to same period, then from top to bottom in a group, basicity decreases, nucleophilicity also decreases. Nucleophilicity decreases in polar aprotic solvent. Nucleophilicity increases in polar protic solvents due to solvation effect. Polar protic solvents form hydrogen bonds. That's why nucleophilicity increases. Basicity decreases, nucleophilicity increases from top to bottom. Basicity, nucleophilicity both are decreases from top to bottom in a group, from left to right in a period. All are decreases. This one is also in rule number 3, left to right in a period, basicity, nucleophilicity decreases. In rule number 4, from top to bottom in a group, basicity, nucleophilicity both are decreases. This is different. Nucleophilicity increases, that too in polar protic solvents due to solvation effect or formation of the hydrogen bonds. Let's see example, fluorine, chlorine, bromine, iodine belongs to same group. In a group from top to bottom, basicity decreases and nucleophilicity in polar aprotic solvent decreases, but only Polar protic solvents nucleophilicity increases. Basicity decreases, nucleophilicity decreases, but only in polar protic solvent nucleophilicity increases. Last rule number 5, this is for same species in different solvent. For same species in different solvent, in polar aprotic solvents, species have more nucleophilicity. For example, chloride ion in aqueous and aqueous means polar protic. DMSO, dimethyl sulfoxide, is polar aprotic solvent. In which solvent this species chloride ion has more nucleophilicity? Polar aprotic solvents, chloride ion has more nucleophilicity. This is rule number 5. Take this one. In attacking reagent, this is the last topic, that is ambident nucleophiles. In nucleophile, it is a separate category. One species has two nucleophilic center. With two nucleophilic center, it can attack on substrate. Such attacking reagent, such nucleophiles are called ambident nucleophiles. So, a nucleophile which contain two nucleophilic centers. Through those two nucleophilic center, it can attack on substrate. Example, cyanide ion. In cyanide ion, carbon is one nucleophilic center, nitrogen is other nucleophilic center. If carbon is nucleophilic center, that becomes cyanonucleophile. If nitrogen is nucleophilic center, that becomes isocyanonucleophile. Second example, nitrate ion. In nitrate ion, this nitrogen can act as nucleophilic center, this oxygen act as nucleophilic center. If nucleophilic center is nitrogen, that is called nitrate ion. If nucleophilic center is oxygen, that is called as nitrate O. Nucleophilic center, here carbon or nitrogen, which can act as nucleophilic center. Between nitrogen and oxygen, which one act as nucleophilic center, that purely depends on reaction condition. So, nucleophilic center by which nucleophile attack? With carbon or nitrogen? With which nucleophilic center this nitrate ion attack? With nitrogen or oxygen? That purely depends on what? Condition, such as which solvent we are using, which temperature, high temperature or low temperature, and also nature of the electrophile. On electrophile, nucleophile attack, if strong electrophile or weak electrophile. So thus electrophile, temperature, nature of solvent decides whether which nucleophilic center, by which nucleophilic center this nucleophile attack. Okay, so HSAB, hard acid and soft base principle, hard and soft acid base concept explain which nucleophilic center, by which nucleophilic center that nucleophile attack based on the condition. Okay, take this one.